Well, good morning, everyone. It's good to be here. Many familiar faces out there. So let me start with a raise of hands of how many people here are actually interested in AI? Okay, a couple guys. How many of you guys think AI is still just a bunch of hype? Is anybody here? Where's all my hype guys? Anybody found AI to be actually useful for anything yet? No one yet? Oh, one guy, okay, that's not bad, that's a start. Anyway, I'm kind of here to give you kind of my overview of where I see AI actually starting to make a difference and why I'm investing so much time in it myself right now. For those who know me, I started my career with aerospace. That's a company I founded back in the early 2000s. And I would say back then, the paradigm was really around trying to help you, most of the IT departments, take care of a bunch of access points. Most of the IT guys I met were basically WISP, right? You're being asked to take care of hundreds, thousands of access points and thousands of wireless users. I see that paradigm shifting now. Over the last 15 years or so, I see Wi-Fi has moved from this nice to have, very hard to sell 15 to something that's now must have. Most of you guys don't even question whether or not you're going to deploy it or not. After Cisco acquired aerospace in the 2005 or 6 timeframe, though, I started to see a transition happening in the space. And I started to talk to more customers who are trying to do something on the wireless networks. And it really came down to, they started to ask me a couple things, before they put any critical services on that network, they wanted me to help them do a couple things. One was they wanted me to help stop the controllers from crashing, because they were going to put something critical on it. The second thing is, if they were going to put a mobile app or some sort of manufacturing service, they really needed to make sure that they had this real-time visibility. They needed to make sure that thing was actually connected to the network. And the third thing was really around this, what I call innovation for speed. They would ask us to do something, and our answer was, it's going to take me 12 months to get something done. Yeah, that sounds good. I'll get it on the next release, and maybe next year we'll have it available for you. So those are the three things. Whoops, what happened there? I don't want to quite go there yet. But those are the three things that kind of drove me to this, okay, there has to be a different way of doing it. The controller architecture was fine for back then, but to solve this problem here, we are going to really need a slightly different architecture. And that's where I got into this, the difference between distributed software architectures and embedded architectures, right? What we had really built back at Aerospace was a very embedded software architecture. That was an architecture where we put software on top of a Linux box, and it was a good architecture for its day, right? But what happened to that architecture over years, right, as we kept adding more and more code to that architecture, it really ended up being what I call spaghetti code, right? We kept adding, and we got into a paradigm where we were basically building code for 3 months, but we were trying to spend 9 months to try to get all the bugs out of that thing. And we got to a point where you just could not get all the bugs out of the architecture. And that's when I started to realize, the underlying architecture has to change. We have to get that fixed first, right, if we're going to build on top of it. Back then, my Cisco days, we had just acquired a cloud company. And originally I thought, we'll do this on that. I got a cloud, we will basically build on top. What I found when I looked under the hood, it's one thing when you're building something for configuration, right, taking data from all the access points, sticking it in a database, and making it easier for people to deploy and configure things. It's another thing when you actually want to build something that's actually going to process data in real time at scale. And that's when I started to appreciate that these software architectures are different, right? If you want to do that, I really want to build something that's leveraging the latest cloud stack, right? This is all that LinkedIn, Netflix. These are architectures that can ingest a lot of data at time. These are very resilient architectures. The concept of a controller. I recently was at a meeting, and someone had a hard time kind of really realizing, this is not putting a controller code into a VMware container and running on the cloud. That inherently does not change the architecture, the underlying software architecture doing that. When you actually get into these cloud architectures, you will start talking about virtual machines, doctors, instances. I am running RRM for the whole country, right? I don't run RRM for a customer. I run RM as a service. And if one of those services dies, it automatically picks up another one. So that's that resiliency, a part of, I don't have to worry about things crashing anymore, right? And they're in the code. The third thing about this architecture is really the speed, right? I can release code every week now. And that becomes critical, especially around this AI, where we're innovating. Things are moving fast. Algorithms are changing every week. You don't want to wait a year to get your new algorithm updated. So the first part of this vision, if you remember the other slide, right, it starts with data. And for those who know me really well, I make a barrel of wine. And I tell people, if you think making wireless is hard, making wine is even more complicated. There's more stuff going to that. In a wine business, it really starts with grapes. If you don't have good grapes, you're not going to make good wine. The same is true with all kind of this AI stuff. If you don't have good data, you're not going to be able to figure out what's really going on. And this is one reason, when I started MIST, I actually decided to build an access point, right? Because I want to make sure I had control of the data. I want to make sure I want to get access to the right data. And in that paradigm shift, this time around, it's not about helping you manage access points. It's really about helping you manage the end-to-end user experience, right? This is about trying to make sure, why is that person not connected? Why is that barcode reader not being able to get to the internet? And that requires a different set of data from the access point. In addition to all the AP stats that we send back every 5 to 10 seconds, we're starting to send back user data. This is state data. This is asynchronous state data that comes back from that access point that tells me what's going on with the actual device at the other end of this packet. And this is what allows you to start doing things like little bits of anomaly detection at the edge, right? Because now we're basically looking at the data coming in at the access point and around that device, right? And that's what enables us to start doing things like this dynamic packet capture, right? That's what allows you, when you detect a problem at the edge, you actually capture the packets at that moment. So when you as a wireless IT person needs to come back and figure out what happened, you have the evidence and the packets in front of you to do something with it. So this is why it's critical to have, when you build these AI architectures, you almost have to go all the way back to the access point and start from there. The second piece of the journey here is really along, what do you do with that data? If you think about that data coming back from that access point, those are fundamentally log files. And there's two options when you head down this AI path. Is one, you can treat it like unstructured data, and they have algorithms that you basically start with, I don't know anything about the data, and I'm going to classify it, right? And I can start sending that stuff through neural networks and basically try to auto-classify those events coming back from the access point. The path I chose to go down was more of the structured data, right? I'm taking that data from the access point, and I'm putting some structure around it that a domain expert would really understand, right? And this is what we call SLE metrics and classifiers, right? These are metrics like time to connect, roaming, coverage, AP uptime, anything that you as a wireless network IT guy would normally want to know about in troubleshooting a problem. It turns out when you're actually trying to build an AI solution, some part, we're automating what you're already doing, right? And that was kind of my other vision when I started MIST, right? There's a couple things that got me going. One of it was, let's see, how many of you guys remember the Watson Jeopardy thing? You guys all remember Watson playing Jeopardy? Yeah, so I decided that, hey, if they can build software that can play Jeopardy, we should be able to build software that can answer questions on par with a network domain expert, right? You guys are all network domain experts out here. And this is not in the sense that this AI is going to replace you. This is more about trying to make your life easier and more efficient, right? This is basically, when you think AI, for me, when people say AI is a concept, right? AI says you're building something that's trying to do something on par with a human being. You're trying to do a self-driving car. You're trying to build software that can basically interpret medical records on par with a doctor. In this case here, the vision is we are trying to build something that can answer on questions on par with a network domain expert yourself, right? So in my vision right now, we're building something that can actually do that for you. That can help you answer these tough questions, either easy questions like, how many DHCP servers I have or how many clients are on my network, or the harder questions like, why is, John having a problem? Why is a site having a problem? So what you're seeing here in this little video here is what you would do normally, right? If someone were to call you up, you would start working your way through log files or dashboards to try to figure out, why is your CEO having a hard time on the wireless network today? And so this is the beginnings of putting structure in place for this, for what I call Marvis, or AI component. It turns out that you actually find it useful, right? The same thing I need to make this AI Marvis thing work is the same structure that you find useful. Yes, I want the data organized and structured in a way that makes it easy for me to troubleshoot from the top down to a specific person. So that's the beginnings, the second step in the journey. So when you look at the journey, we have the data. We've taken data from access points. We've put it into some structure that you, as a network domain expert, can actually troubleshoot a problem down through automatically. The next component of this journey is really around what I call the data science toolbox. And this would be a curious thing when I've talked to, professional Wi-Fi professionals like yourself. The question is, do you guys really need to understand this piece of the puzzle? How deep do you need to go? I mean, should there be workshops here for people here to really get down to the details of how these different algorithms work? Or are you just interested in knowing, I don't really need to know how it works, I just need to know what it does for me? So I take another raise of hands. How many people here are really interested in getting to know how these algorithms actually work and how they're used to make a self-driving network? See one, I can see a couple people. Now this chart here begins to kind of break it down for you in terms of what is going on under the hood, of Alexa, right? If you look at your Alexa that's trying to do all that voice interpretation or some sort of image analysis, it's not one algorithm, right? There's a whole bunch of different things happening to pull together something that's driving a car, right? If you went to a self-driving car, you'd find a whole bunch of junk, a whole bunch of sensors and a whole bunch of algorithms happening. In the case of networking, what we're looking at here is, what you'll find in the industry is when people say AI, they tend to associate that with neural network, deep learning, and that's because deep learning has radically disrupted several industries, right? Deep learning, when it comes to image recognition, deep learning has pushed that to a next level. When it comes to speech recognition, deep learning is what made Alexa actually work, right? All that speech learning stuff was kind of weak before deep learning came along. In our industry, it's not quite clear where deep learning is actually going to make a difference for networking yet, right? Where is deep learning going to disrupt wireless networking, networking in general, and solve problems in a new way that we haven't solved them before? So when you start to kind of understand this space here, you kind of see on the y-axis is the level of relevancy, right? In terms of if someone says AI, what would you expect to find behind that AI solution? The x-axis is telling you complexity. And that is why AI has become more relevant today, why you're hearing the marketing buzz. If you get through all that marketing noise, it is starting to make a difference in different industries. And it's because these neural networks that we weren't able to use before are now actually useful, because now I have enough compute power and we have enough data. Most of these models require a lot of data to either train or feed. And that's the other key part of why it's, why you're hearing so much marketing hype now. This is an example of, I thought, of going over a real use case of something they call mutual information. So mutual information is a technique where you basically have two random variables, and you're basically trying to answer the question of how does one random variable predict the outcome of the other random variable? And this is really relevant back to that SLE framework, right? So if you look at the framework, how we've structured that data, one of those random variables is what we call an SLE metric, right? And that metric can either be true or false. It can either be, for that particular user, did that user's roaming work? Did that coverage work? Did his connection work? So that's one random variable in the equation. The second random variable could be any one of a bunch of network features, right? This could be client type, AP, DCP server, and this is what you do automatically, right? Most of you guys, when you actually troubleshoot a problem, you are trying to figure out what went wrong, what feature caused the problem. You're trying to break it down. And for the most part, if it's a simple problem, you can get to it quick, right? It's like, hey, I know the DCP craft, that's simple. It gets when it gets more complicated, when there's more layers, where the problem is the result of like an airplane crash, right? It's not one thing that caused it. It was a couple of different things, right? It's a router that got misconfigured that caused a broadcast storm that eventually led to something bad happening on the wireless side of the thing. So mutual information is a technique that allows you to basically answer the question of what network feature actually caused one of those metrics to fail. And when you go through all the math, it's kind of an interesting thing to work through the math, and it's like, it really works. You take 50 network features, and that will pop the most interesting one in terms of which SSID actually caused the problem, right? Is it a client problem? Is it a systemic problem? Am I having a problem across all my networks? One network, one SSID, one device type? And this is what allows that previous video, allows you to quickly troubleshoot down to, hey, it's this, it's not all my network, it's one device type, it's a misconfigured Windows OS that got misconfigured at midnight that start to cause the problem at the site in England. And these are kind of real examples where we're dealing with customers that are actually starting to figure out the value of this, right? And so this is starting to speak to, when you get into it, you will actually start to understand this more. You will start to make your life easier when you want to try to automate that troubleshooting process and try to bubble up what's really going on inside of your networks. This is another interesting case, anomaly detection. For me, the analogy here is kind of like voice recognition, right? Voice recognition wasn't really good until deep learning came along. Anomaly detection, the same thing. We've been trying to do anomaly detection over the years for various reasons. It's not really recently until we got to a point, though, with these neural networks that we're starting to get anomaly detection to be really effective. And the reason you should care is they do make a difference. This is a case where, yes, as you start to get these neural networks to actually help you on your time series anomaly detection problem, they will detect real problems in your business. We've had several cases now where someone tried to push a change at 2 o'clock in the morning, and the anomaly detection is now able to catch that change. We can basically, there's a case with a very large customer who does distribution globally. They did something, they misconfigured a thing. The anomaly detection actually picked the problem up at like 2 o'clock in the morning, and we were able to stop them from rolling out that change. They were about to roll it out, globally across like 50 distribution centers that would have basically brought those distribution centers down. So that's why you need to start embracing this and figuring out how to use it and how to leverage this machine learning. To the previous gentleman, right, anomaly detection by itself is, and I'll point, is not AI, right? Yes, building an anomaly detection algorithm is interesting and useful. That by itself is not AI. Building something that can answer a question on par with a domain expert, that's an AI concept. And so that's the subtle difference between learning how to leverage an algorithm and actually trying to build an AI solution. The other thing you should care about this, yes, it does help your business. It will save you, it will save your networks from going down. It'll be proactive, so you don't have to wait for the call to come in. The other thing is this stuff starts to eliminate the false alarm. The reason people don't do this right now is most of this stuff generates too many false alarms at 3 o'clock in the morning. right? And no one, and we get, we have some very big customers who they do not appreciate getting a 3 o'clock in the morning false alarm because the anomaly detector told them that they have a problem somewhere in India, right? They don't like that. And that is where these neural networks are starting to make a difference, and they're getting more accurate with fewer false alarms to go with them. Another one favorite use case of mine is, as Frank was mentioning, indoor location has been one of my passions since aerospace. I did indoor location at Sparespace. I did Wi-Fi indoor location. One of the things I never could really do was learn these models, right? This is the RF path loss model, right? Up to now, we basically usually tell people, please go do a site survey. You go learn this model by walking around. What I can tell you right now, what we have is you can actually use these models now, unsupervised training, to learn this model. So what and this is your RSSI versus distance model. Let's see, how many indoor location champions do I have here? The wireless, any indoor location? I know Frank is out there. This turns out to be a relatively hard problem, right? But this is a case where machine learning also allows you to now learn this model from just the data walking around, like all your phones here, while you're connected to the network. In this case here, this is a BLE use case here, where we are basically listening to all the BLE signals coming from your phone. We are basically turning that into, what I call the valley of happiness, right? And so by taking all that information, you basically, on the y-axis is the PLE, right? That's the slope. That's the slope of the line. The intercept is the 1 meter point that you're trying to figure out. If you take all that data and stick it together in this chart here, you can start to figure out what PLE intercept actually is going to make a difference. And when you look at the valley here, you can see how steep the valley is, right? And this is why it makes a difference. You have to be in that valley. If you want to optimize the user experience and get the location accuracy as low as you can, you want to find the PLE intercept that puts you in that valley. You will find, the interesting thing from doing this now, I've looked at probably hundreds of devices, different mobile devices. I can tell you that iPhones hear BLE a lot better. Surprisingly, I always give Apple a hard time for their antenna technology, but surprisingly, iPhones hear BLE 6 dB better than Androids. And this is what you're trying to learn. You're trying to learn the difference between all these devices, and you're trying to learn it across space. So this is a good case of where, 15 years, back in my early 2000s, I could not have done any of this. I thought about it. I wish I could have done it. The reason I couldn't do it back then is I couldn't get all the stuff to run on a 1U Linux box, right? There just was not enough memory horsepower to make it run. There was not enough memory horsepower to do it. Now with Amazon and the cloud, I'm just limited by dollars, right? It's like how much money, I pay Amazon enough money, yes, I can solve any problems. I found in life there's two things, right? Any problem can be solved if you have enough money and you live long enough, almost anything can be solved eventually. Now, this is kind of highlighting where does this AI start to make a difference? So this is the NLP piece of it, right? Because now we are trying to get to I want to answer a question on par with a domain expert like yourself. And my vision is someday, if I ever get this set up, and we're going to have wireless Jeopardy here, right? We're going to have a little game contest, and I'll have, the world's best wireless IT guys up here trying to play Marvis and see who can get to the answers faster and quicker. Now that would be kind of a fun exercise, don't you think? We should get the best wireless IT guy in the room, and we'll set up a little wireless Jeopardy contest. But this is where it starts to come together to make your life better, right? Because this is where you are ultimately trying to answer questions as fast as possible. And where AI is going to make a difference, it's going to make a difference in terms of trying to get you to the right data faster and quicker than you could by yourself, right? It doesn't say it's perfect, but it's going to try to make your life simpler and easier, whether it's a simple question. And when you look at some of this stuff is what I call Splunk, right? You know, if you ask me how many wireless users are on an AP, or please sort the wireless users by coverage, those are relatively simple questions that you're asking a database. You know, that's kind of your Splunk use case of, yes, I want the data organized so I can basically query it quickly and get the data answer out quickly. The harder questions are trying to answer the questions of why did your CEO have a bad user experience at 10 or 11 o'clock yesterday? Or why is the site in England gone down that supposedly looks just like every other site, you know, but something in England is not working. One of your distribution centers in England has gone down. The other key part that I believe with all these AI solutions, what I found working, you know, in the industry and with IT for the last 10 years is you guys don't trust anybody. You know, when it comes to, you know, your networks, whether it's a person or an AI, you don't trust anybody to turn your knobs. They have to be pretty good friends before you let someone start touching your switches, routers, and APs out there. I think the same is true with AI. You know, there needs to be a feedback. If this is going to be your virtual assistant, you need a way of saying, hey, Marvis, why do you think that's the answer? And so this is the other component of making sure the data is available to you so you can actually investigate and look at why does your AI believe they understand the root cause to some problem. To the point where eventually, once you trust it, you may say, please don't bother to tell me that again. I trust you got the right answer. But I think most people say we're still a couple years away from the true vision and the true promise of AI coming your way. You know, and this is basically showing you the power, you know, this is basically showing you all that mutual information and that time series anomaly detection of trying to give you the evidence of why we think coverage is a problem or time to connect is a problem or roaming is a problem or you have some sort of route switch problem. You know, it's amazing, you know, when I've been doing this for a while, most of your problems are not, it's spread across, right? It's the, you know, a third of your problems are somewhere the device screwed up. The other third of the problem is the AP itself screwed up. And a third of the time, someone has screwed up a switch or a router configuration on your side. I mean, I just had a case recently where the customer was blaming the wireless, you know, for all his connection problems. And we went round and round and round on it and going, hey, it doesn't, you know. But eventually, Marvis came back, and what had happened was they had configured 3 routers, and those routers stopped forwarding large packets, right? You know, so someone at midnight basically misconfigured the router on our POC network, no other network, so that's why they were sure it was our problem. You know, this was able to catch it, right? Because we knew at that point at midnight what had changed was the network was starting to drop packets, right? And that's the type of stuff that takes you a long time to sort out through the log files. You know, it's not that you could not have gotten there. You would have eventually figured it out. You know, to be honest, it took us probably 6 hours with the customer to go sort out what had really happened, right? And that's the type of problems that we are trying to basically start to improve with this AI machine learning stuff, right? That correlation should not take you 6 hours to figure out. A piece of software should be able to quickly come back and say, yes, your router got misconfigured at midnight, you dropped large packets, and that's why your wireless connection stopped working at midnight that night. In terms of where are we, you know, in my vision right now, you know, I started NIST with the vision of building a self-driving network. You know, just like Elon Musk has a vision of self-driving cars. And I think, believe it or not, I think all of us here, even myself, may live long enough to see a self-driving car. I think all of you guys will live, I think most of you guys will live long enough to see a self-driving car, and I think you will also start to see a self-driving network. You know, what this graph kind of shows you is where are we, you know, where am I right now on the journey of delivering a self-driving network? You know, so right now I have a support team out there supporting customers, right? So this is a group of guys like yourself. They're responsible for supporting all the MIST wireless deployments out there. They deal with all the support tickets and calls that come in at them every day. So right now we have them actually using Marvis. It's like, let's find out how many questions, can this AI stuff answer on par with them. And what you see in here is the blue is kind of the, okay, Marvis had the answer. This piece of software, they would ask the same question that someone calls them up and says, hey, I had a problem yesterday at the library at 12 o'clock. My users can't connect. Can you tell me what happened? So about 20, 30% of the time, Marvis now has, yes, they got the right answer. They didn't have to go any farther than that. Some percentage of the time, Marvis had the data but didn't get the right answer, right? The data was somewhere there, but we didn't get the right answer. The third case is Marvis wasn't helpful at all, and they had to go back to dashboard, right? They basically went back to the dashboard to kind of start troubleshooting and getting down to the root cause of what was happening. And then the fourth item is data in the cloud, okay? Even the dashboard didn't have the data. They had to go back to the cloud to figure out what was going on. And the final thing is they had to go log into an AP, right? That's the final straw, okay? Let me just go down to the AP and see if I can figure out what actually happened at that site. So this is giving you kind of a, where are we on the journey right now? My proposition here is AI is real. This is kind of the state of where, I am currently at. I have a piece of software now that can answer questions on par. I have a piece of software that can answer questions now. So AI is on the racetrack. Is it playing championship level at the moment? No. I'm probably playing, if I look at the data here, I'm at 20, 30%. Have me come back next year. My goal is to have that at 80%. By next year, I want to have this playing championship level, wireless Jeopardy, getting 80% of the questions coming into my support team up at the 80% range. So if you step back and look where we are, right, and this is why this is a journey. It doesn't happen overnight. I've been at it for 3 or 4 years. Took me a half a year just to raise money, so that I don't really count that year. But the first year was really building access points, getting the data that I needed to solve the problem. Second year is basically applying structure, taking all that data and getting some structure to it, so that you as a domain expert could actually use it to troubleshoot something manually if you had to. But that's the framework of actually getting the software, AI software, to actually do something. The third year was really starting to build the toolbox. And this is really starting to get the algorithms to see, what is it going to get time series anomaly detection to work with low false positives. I would tell you I've gone through 3 different time series algorithms now trying to find one that actually does the job. When I've gotten to LSTM, RNN is kind of, okay, I'm getting to good accuracy, low false positives. I tried ARIMA. If you may see how many people here wake up in the day and worry about ARIMA versus LSTM. Trying to figure out which one of these algorithms is really going to not wake you up at 3 o'clock in the morning. That's the type of stuff I'm interested to see in this group, right? Because I've come to this, I think I've come to WLPLC a couple times. I've come here a couple times. I'd be very interested after to talk to people what they want out of their, how much of this AI stuff do they really want to go down to? I would say from a wireless IT point of view, you should have enough knowledge to understand how the algorithms work, like mutual information, the difference between LSTM and ARIMA, which ones are going to give you low false positives and better accuracy. That's my theory right now. The other theory is that, hey, this is, as long as it works, doesn't really make any difference. As long as anomaly detection work, it doesn't really make any difference what's going on under the hood. The third piece of the puzzle that I'd be highly interested in getting feedback on is around the interface. I'm investing time and energy around these NLP, right? And so this is another thing where all these natural language processing interfaces, all this stuff is really based on, recurrent neural networks. This is a bunch of text processing thing that do a better job of interpreting the questions. So you can basically start answering questions in a very more natural way. And the theory here is really around, as we start to build these AI type of solutions, that it'll become more useful to a larger population, right? That you get more into self-serve. And you'll see this going through all the data analytics thing too, right? Is can we make the data more available to more and more people to help them get their daily job done? And so that's the kind of the query language, should you be a query language specialist, or should you be able to answer questions in a much more natural language way, or do you have to be an expert in some query language to start using the system? So this is kind of where I'm at in the journey. I'm on the side, I firmly believe that yes, when it comes to wireless networking, these machine learning algorithms and using them to actually build something that can answer questions on par with domain experts is going to make your life easier. Similar to self-driving cars, I'm not going to let my car drive itself right now. I don't think I've seen anything I trust to take my hands too far off the steering wheel. I think the self-driving network is on the racetrack. I don't think you guys are going to take your hands off the network. I don't think you're going to, I think we're at the point where you're going to hand your network over to a self-driving Marvis AI piece of software. But I think you're going to start having to leverage it. You're going to find out people who actually start leveraging this stuff are going to be able to move faster, resolve things quicker. Things are going to become more real time. Your businesses are going to become more real time, either on the consumer side. Either you're going to have your marketing guy want to do something on your network that's a real-time mobile app experience, or you're going to have your operations guy start to come to you and want to put more business-critical operations outside these networks. So with that, I'll open up for a couple of questions. Any questions, thoughts? AI still a hype? Let's see how many converts I got. Have I converted anyone from, hey, there's more to this AI than marketing hype? Let me see. Okay, I got a guy over here. He's starting to see there's some light here. Yeah. 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 Let me see if I got the question. I think your question is something along the data flow. What's the efficacy of the data? I think you're getting down to like Broadcom and Theros. Ultimately, this data is, if you dig down to it, and that's why the access point is critical. And that's why I built an access point and put software on that access point, because that data starts right down at the Broadcom or Theros chip, right? All the utilization data I get, all the coverage data I get, if that data is not good, then all my other analysis is bad. So yeah, if that's your question, it's critical that yes, you've got to get down, and you have to have domain experts, right? You have to have people who really understand Broadcom and Theros, drivers, and how to get the data out of the access point back to the cloud. And I would tell you that's a critical thing. That's another thing I found in this adventure was, and another reason why I left Cisco, right? Otherwise, I would have stayed at Cisco and have done this, is that, I firmly believe this is a blank sheet of paper. This is something that requires you to get a team of domain experts, cloud experts, and data scientists, right? These guys all have to live together right next to each other to solve this problem. And usually that's hard to do in a big company. Usually these groups are scattered across different boundaries. And that's usually what happens when you see things disruptive, right? When things disrupt an industry, you're usually finding different types of people having to work together. So in this case here, we have hardcore wireless experts who've been in the industry for 20 years playing around with Linux and Broadcom and the Theros drivers getting that data that we need out of the AP back to the cloud. I think that was your question, right? Yeah. So I mean, that is, yeah. This will not happen without the data. If you don't have good data, this is, you're not going to get to good answers. Any other AI converts?
Going through the facts and maybe doing some statistical analysis. But this seems much more difficult because you're collecting real-time data, deciding what data to collect, how to categorize it, and then doing statistical analysis in addition to that on top of it. So, I mean, do you see a difference in this and Watson being more like just a Google search?
Yeah, I mean, the analogy breaks down. It's not quite, as you point out, it's not quite apples and oranges beyond, because Watson was really designed to answer open-ended questions, whereas we have very specific questions we're trying to answer. So your point, is this harder than Watson? Maybe in our own way, because I need a domain expert, right? I've got to have a wireless domain expert. I've got to have really domain expertise on the team to get this problem solved. So in that sense, it's harder. If you actually go back and watch the videos on Watson, it's kind of interesting, for me, because the first time they tried to play Jeopardy, it didn't play very well, right? And it's so I kind of feel like with Marvis, okay, I've got Marvis working. It's playing 20, 30%, right? I get 20, 30% of the questions answered, but I'm not at 90% yet, right? And that's where I want to get to. So in that sense, it's very similar themes, but you're right. Technically, you look under the hood, the algorithms are totally different, right? They were solving different problems, right? They had Jeopardy. They had funky problems of trying to classify a question, right? They had to kind of figure out whether or not it was a trick question or a regular question, right? So they had to build classifiers that actually did that. I'm building classifiers right now that have to figure out, why did time to connect not work, right? Is it a DHC problem? Is it an association problem? Is it some combination? In that sense, it is different. The classifiers I'm building are different. They didn't have to worry about time series anomaly detection. They weren't trying to predict anything. Here we're actually trying to predict things, right? In addition to troubleshooting, we're trying to predict things that go wrong. Okay? Any other AI? And I'm hoping by now that by next year, we will move from the AI hype discussion to more of the, what algorithms are actually working, right? I mean, I'd love to get to the ARIMA versus LSTM discussion. What are you guys finding useful out there in making your life better? And that's it.
Yeah, one more question. While you were talking earlier, so I just want to be sure how you collect the data. So is it based on historical data, or the AI reacts immediately? Because, for instance, I saw you showing throughput data and stuff like that. So how are those data collected from the clients? Because when the AI is reacted, for instance, let's say there was an interference, is the interference data historical or is it real time, and then how is it responding back to give the data back?
Yeah, I think the question around, is the AI working real time or batch mode? Exactly. We do both. Like the location, that's real time, right? I've got to come up with a prediction every second, right? When you're walking around, that's a prediction every second. When we get to networking problems, we're probably predicting things. We can predict every second if we wanted to. Most networking problems, you're predicting on the order of minutes, right? I want to make a prediction over the last, given what I see over the last 5 minutes, I want to predict the next 5 minutes. And so that's kind of the networking time frame. So in location, seconds, right? That's sub-second predictions. We're taking data, processing it, and making predictions every second. In the networking world, we're typically making predictions every 5 minutes, right? I'm trying to predict if something's about to go wrong, or I'm trying to figure out some anomaly thing within, but I want to do it real time in the sense, if a distribution center goes wrong, I want to know it within minutes. I don't want to wait for the person to call me, like the front desk. If I'm at a hotel and you have a wireless problem in your room, I want the front desk to know before you call the front desk. So that's my definition of real time. Okay, with that, I want to thank everyone. Don't hesitate to send me emails, happy to talk about. Comes to AI, indoor location, or wine. All three of those topics are at the top of my favorite list right now, so don't hesitate to reach out to me. Okay, thank you.
Thank you, Bob.